Okay, so before we begin talking more about the oceans, I thought I'd put a slide in to help you review a little bit. So this is the carbon cycle. So what I want you to do is take a minute. You can pause the slideshow and see if you can fill in 1 through 7 using the word bank. All right, pause it. All right, so how did you do? Do you think you have the answer? So here's the answer key. So don't forget to go over those various cycles. Remember carbon, nitrogen, sulfur, the water cycle. Those are all really important, especially carbon and nitrogen. I think you'll see a lot. Okay, so the oceans. So what I want to talk about in this slideshow is mostly human use and impact. So what do we use the oceans for, and what are the impacts of those uses? Okay, so this is kind of a general outline. So we're going to talk about the uses for food, energy and minerals, and transportation. And then impacts are going to fall into 2 main categories: pollution, and then the fact that we're emptying the ocean. So over-harvesting and its consequences. And then once we talk about all this, we'll tie it all up and talk about some possible solutions. All right, so let's start talking a little bit about the human uses. So transportation is something that people have always used water for, and the ocean. So it's a great way to transport goods from one site to the other, and we still use this today, especially for large cargo, oil transportation. So these are really huge ships. And so we're worried a lot about what types of pollution they may be causing, the fossil fuels that they're using, and then what to do with them when the ships are actually of no use anymore. How do you break them down safely so that various things aren't causing more pollution? In addition to transportation, we also get energy and minerals from the ocean. So as you learned when we talked about the Deepwater Horizon, there are more oil wells being drilled in the ocean and deeper. So that causes some problems into trying to figure out, well, what do you do if there's an accident? How do you control it? But we want to take advantage of those resources. So especially in the Gulf of Mexico and the North Sea, up where England is, those are really large areas where people are drilling for basically crude oil and natural gas deposits. Okay. In addition to those, though, we are exploring ways that the ocean may be able to give us some renewable energy. So things like wave energy, tide energy, heat of the ocean. Can we use any of these things on a larger scale to provide for some of our energy needs? All right. In addition to energy, there's also various minerals and other things that we can basically mine from the ocean. So things like sand, gravel, calcium carbonate, silica. So those are things used in cement, for instance. Minerals such as copper, zinc, silver, gold. All of these can be found on the ocean floor, so people are trying to figure out how to get to them. And then lastly, food, right? So this is the big thing we'll circle back around to when we talk about overfishing. But people have always used the ocean as a source of protein, especially all those coastal communities have used fishing as a resource. And we can see this, in the Chesapeake Bay. People always harvested the oysters and the crabs. But now with the advent of technology, we are harvesting more than can be sustainably replaced. So we need to think about how that's going to work. Okay, so let's start off talking a little bit about pollution. So I've come up with basically 4 main categories. So nets and plastic debris, oil pollution, toxic pollutants, and excess nutrients. So nets and plastic debris, this is in the news a lot lately, right? We've all seen, I think I've shown a few pictures of, isolated Pacific islands that have just trash strewn all over them. Because remember, plastic is not biodegradable. It doesn't break down. So any that finds its way into the ocean is basically going to stay there, okay? And so here showing basically a plastic bag. To a turtle, this looks just like a jellyfish. So all of these plastics cause problems because things like birds and fish and turtles don't know, and they eat that. And we're finding more and more of these marine organisms that then have tons of plastic in their gut And obviously that's not providing nutrient value, and it could prevent them from eating other foods. Another source here is fishing lines and nets. So all of the fishing that goes on in the ocean, right? Those nets or those lines, sometimes they tear, they break off. Sometimes people just throw them overboard. And all of those lines then get entangled around various seals and fish and turtles and sharks and whales. And so all of that causes problems. All right, you've probably heard about the garbage patch in the Pacific Ocean. So this is areas in the ocean where gyres form. So these are areas where the currents are coming together in such a way that it's sort of delivering more concentrated pollution in that area. And these are just areas that have a large amount of those plastics floating in it. If you remember back in the beginning of the year, we talked a little bit about the gentleman that was trying to design a system where ships could skim for the plastic pollution. So that was what he was basically dealing with. All right, so that's net and plastic debris. All right, and then we also have oil pollution. So this is a pie chart that shows the various sources of petroleum input into oceans. So there are natural seeps. So these are just areas in the ocean that various types of oil, natural gas are going to seep out. And that's quite a large amount. But here's also a huge input. This is consumption. So this is oil that washes off of roads and surfaces. That's basically a byproduct of how much we consume, right? This is from transport, so oil spills, tankers that spill things, accidents, anything like that. And then this is due from extraction. So again, either accidents or just oil that's lost during the extraction process. Okay. This is a chart showing basically oil spilled from tankers, okay? So, and you can notice that there were really huge numbers kind of early on. And then starting about the 1990s, there have been series of laws. In the United States, there was the U.S. Oil Pollution Act of 1990. And this was trying to mandate basically safer shipping methods. So one thing you'll hear about is tankers now have to be double hulled. So there's two hulls basically, so that if one gets broken through, the oil is still not going to escape. Unfortunately, there still are a lot of really old ships that are out at sea that maybe are from countries that don't have the same enforcement or regulations that we have. But this is decreasing. Okay, and as I mentioned, Deepwater Horizon was one of our case studies, and we also talked a little bit about the Exxon Valdez. So if you want to review, go back to those biozone pages, and you can read about those. And then here's a vocab word from the past. Remember what bioremediation is? So this is the idea that we're going to try to figure out ways that bacteria can help take care of some of that oil pollution. So when a ship runs aground and starts leaking oil, can we use biological means to sort of break it up? All right. You'll also probably, when you look at these biozone pages, review the other methods that people use to clean up oil spills. Okay. And then obviously the problem from all these oil spills is it coats marine organisms, right? We've all seen the pictures of the seabirds that get coated with oil, right? And they have to clean them off with Dawn dishwashing detergent. It poisons when ingested. So this can be really detrimental to ecosystems, especially more sensitive areas that the oil might spill. Okay. The other type of pollutant would be toxic pollutants. So these are mostly things like our heavy metals that we talked about in chapter 14. And in particular, we worry a lot about mercury. So remember, mercury is a neurotoxin. And it has some natural, so volcanoes will emit mercury, but also burning coal, especially sort of the lower grades of coal that have more mercury in them. And then mine waste and runoff also contains mercury. So this mercury then flows into the ocean. And then look what we have here. Here's our food chain, right? So here's krill. So mercury bioaccumulates in the krill because the krill then can't get rid of it out of their system. And then as you go up the food chain, our mercury levels are increasing. So that's our biomagnification. So you'll often hear warnings for people to not eat too much of these top predator type fish because they accumulate more mercury. And this is especially important for pregnant women because, remember, it's a neurotoxin, so it's going to affect the developing fetus if you have too much mercury. All right, and then I think we'll hear one of our case studies next week will be about Minamata Bay. And so that's a discussion of mercury poisoning. All right. And then our fourth type of pollution are basically excess nutrients. We've talked about this numerous times. So hopefully at this point, you know, nitrogen and phosphates, fertilizer runoff, sewage runoff can cause these. And we talked about how they cause dead zones, right? But what I want to mention here is in addition to dead zones, so this dinoflagellate is an example of a type of algae that can bloom in the presence of these excess nutrients. And some of these algae, when they bloom, they actually produce toxins that attack the nervous systems of vertebrates. So these harmful algal blooms are called red tides, basically because they turn the water reddish or brownish. In the Chesapeake Bay, sometimes you'll hear the term mahogany tide, but these are basically the same thing. So these are algal blooms, and because of that toxin, they cause fish kills. So again, in the bay, you'll hear this sometimes, that there's fish kills in this river or that river. Florida has had a huge problem with red tides in recent years, and you just get dead fish washing up on the beach. So, you know, it's an economic hit, right? It hits the fisheries. It hits the tourist industry, right? You can't have those beaches open. It can have human health impacts. So you obviously can't go swimming or come in contact with this. Some of it also can become airborne. So people have respiratory illnesses that are in this area. So along with those dead zones, these red tides are really harmful impacts from those excess nutrients. Okay. All right. So those are kind of the human uses and impacts. But we also want to talk about, remember, our food sources. So we use fish as a lot of our protein sources. And so we want to talk about overfishing and this idea that we're really harvesting fish at a rate that's not sustainable. Okay, so again, we fished a long time over history, and we've actually overfished throughout history. So things like turtles were overfished in the Chesapeake Bay, oyster beds, right? And the problem with oyster beds is you pull up the oyster beds, well, oysters filter the water. So if you now are A, adding more nutrients to the water, and B, taking the oysters out of the water, you see how that's a nice positive feedback cycle, which decreases the overall health of the bay. Whales during the 1800s were overfished for their oil, basically. So this is not something new, but with technology, we've really gotten good at it now. So this is a map, a graph showing capture fishery. So this millions of metric tons of fish, basically. And here's China, and here's the world excluding China. So what does that tell you? Right? China by itself is literally taking in more fish than the rest of the world combined. All right, so that's one takeaway message from this. The other takeaway message is look at what's happening to the catch. So it's increasing, increasing, increasing. So we're improving our technology. And then it's leveling off. So this is a worrisome sign. We are increasing our means of catching fish and going further out, but we're not getting more anymore. Okay? So we'll come back to that thought in a minute. All right, so why are we so good at fishing? So the three main sort of modern methods of industrial fishing are drift netting, right? And that's literally just a huge drift net. And this picture can't really tell you how large of an area this is. And you just literally catch up everything in its path, right? So the fish you want and all the other stuff that happens to be there. All right, long lining. So thousands of lines, right? And then you pull these all in and take the fish off. So again, this is just going to pick up any fish that happens to bite on those lines. And then bottom trawling. So this is catching for like bottom fish, and you literally just trawl along the bottom. So you probably already can see some problems with these. So one, we're going to increase our bycatch. So remember, bycatch is basically the capture of non-target animals. So it could be other fish, it could be turtles, it could be dolphins. You'll notice now when you buy tuna in the store, it says dolphin safe tuna. So they are trying to come up with methods that the fishing industry does not get some of this bycatch. Some of the nets now have are mandated to have turtle exclusionary devices so that the turtles actually can get out of the drift nets. But there's still a huge amount of bycatch going on. Okay. Long line fishing also gets these things because either they're going for the bait or they're going for the fish that are already caught on the line. So even birds can get caught on these long lines because they see the fish and they want to go for the fish, and then they wound up caught on the long line. And here this is showing sharks that are a byproduct. Right? And then that last bottom trawling, okay, here's a coral reef ecosystem before trawling. Here's after trawling. So you've pretty much demolished that ecosystem in the process of fishing. So obviously, once you deplete these ecosystems, right, think about those ecosystem services, right? You're decreasing our biodiversity, and decreased biodiversity means that whole system is going to be less able to withstand disturbances, right? You're going to interfere with food chains. So these are bad situations. The other thing with fishing is we've gotten so good at it, we're really able to deplete marine life very rapidly. And you'll see this with almost like what types of fish you see in the store, right? So years ago, people started to like orange roughy, and it was a really popular fish. And then they literally just fished it out. And now you hardly ever see it. So they've done that with fish after fish almost. All right, and this graph is showing cod harvested. So cod was always a traditional fish that's harvested off of New England and Canada on the east. So this is two areas of the Grand Banks and the Georges Banks. And you can see historically there's always been this, nice catch. And then here's the advent of industrial trawling. Huge increase. Whoop, and then decreased. So they realized something was going on. There were no fish left. So they imposed a moratorium. So basically, we're cutting off the fisheries. And they thought that if they did this for a few years, the fishery would return and they could then allow fishing again. But the problem was they overfished so much that the levels just haven't been able to recover. So once you disturb that ecosystem, there's no guarantee that the ecosystem is going to return to what it was previously. And so that's been a problem with the cod industry. Your book has a little bit on this, and we'll actually watch a little excerpt from a video that talks about the cod fishery. Okay, and this is basically showing what's been happening with fishing. So basically, we've been able to keep our catches up, but that's really masking what's going on. So people say, oh, fish aren't declining because look, we're still getting the same amount of fish. But look what's happened over the decades, right? So here this is showing areas that are fished, right? So the red are areas where there's a real high capture rate, right? And they've kind of already fished out some of the inshore things. Now we go a little bit later, right? These are all fished out, so we go further out. And those are, nice catches. Then here, oh, okay, now we got to go into new areas. And now by 1980, right, less and less of those good areas. So we've been able to keep the rates high by expanding where we're fishing, how far out boats have to go. We're spending more time fishing, so boats are staying out longer. There's improved technology, so we can get anything that's out there basically. And there's probably some inaccurate data. So there's a lot of controversy about especially China and thinking that they're underreporting actually their numbers, so that they're making it look like they're actually reporting, actually getting more than they are. Okay. All right. So one of the things that's happening is we're fishing down the food chain. So we're starting with the big top predators and we're overfishing those. So then we kind of have to keep moving down the food chain. So I thought I'd give you an example of coral reefs. So coral reef fish, this is just a really simplified food web, but you've got large carnivores, right? And you've got large herbivores, and then you've got some smaller fish. And algae, so this is our base of the food chain, right? This is our photosynthesizer. And then you have sea urchins, okay? So the large carnivorous fish are things like groupers, which are good to eat. So we've basically fished out the groupers in a lot of areas. So now, okay, well, we've still got these large herbivorous fish. So these are things like this parrotfish down here. But they're also big enough to eat. So now that they don't have any of the groupers, the local fishermen are going for the parrotfish. So now the parrotfish are being overfished. Okay, so look what's happening to our food chain. So now you've got all this algae and you've lost a main predator of the algae. So this algae is probably going to start overgrowing. Now, maybe that's okay. You've got sea urchins. So the sea urchins could keep eating the algae, but here's where the lack of biodiversity is making the system less resilient, because the sea urchins were taken out by a disease epidemic. So we got rid of the sea urchins too. Now the algae has nothing basically to stop it, and so the algae is overgrowing the reefs, taking over the coral, and completely changing this whole ecosystem. And once the algae grows, it's very tough to reestablish coral in that area. All right, so this probably is familiar. Remember when we talked about trophic cascades? So kind of same area. Now we're just talking about what's happening in the water. Another thing to think about with fishing is we tend to take the largest fish. Well, it happens that fish biology, the largest fish are also the ones with the highest biotic potential. So that's why fish get so large. The female fish are then going to produce a lot more eggs. So the larger fish are going to have more offspring. We're taking the larger fish out. So now we're just leaving a lot of sexually immature fish or fish that don't have that high reproductive capacity. So we're also lowering the ability to replenish the population that way. Okay. So what can we do? So one thing is consumer choices do make a big difference, right? Which fish do we choose to eat? And so one of the sites I want to lead you to is the Monterey Bay Aquarium. So they put out a guide that basically lists like best choices, good choices, and things to avoid. They also now have an app, which I haven't looked at, but somebody should try it out on their phone, see if it gives you a lot of information. So if you're in a restaurant or you're shopping for fish, you can see what type of fish are the best ones. It also requires consumers to ask more questions. So going to the fish market and asking, where did the fish come from? How was it fished? What are the sources? If we demand those things, then we get them. Okay? So that's one thing to think about. All right. Some other things to think about is, remember we talked about how resources are managed. So remember maximum sustainable yield. So one idea is, we need to shift to more ecosystem-based management. We need to think about more than just that one species of fish. We need to think about how the whole ecosystem is interacting. All right. The other thing people have done is try to protect certain areas. So just like we have wildlife refuges on land, all right, let's have marine protected areas. So there's two designations. So there's marine protected areas. So these are protected against some things, but they do tend to allow at least some fishing and some extraction of various things. So the idea amongst environmentalists is that these may not really be providing enough protection. So marine reserves is really kind of the gold standard. So a reserve is an area where literally nothing is allowed. So it's supposed to give those areas time to recover and give the fish kind of an area where there's kind of reserves of that particular species. And so then we have to decide, well, how big should the reserve be? So we want the reserve to do two things, basically. We want it to provide an area where species can sort of recover and be there in larger numbers. But the hope is also that by having some of these reserves, it seeds the areas adjacent. So as the fish recover in this area, they can travel outside, and then the fishing along these areas actually gets better. And this helps promote this among fishermen, saying, hey, if we have this marine reserve here, it'll help your fishing here. So the idea is if you have too small of a reserve, none of the fish stay in the area to start with. They all sort of wind up outside of the reserve, and so it doesn't really do its function. If you have a reserve that's too large, well, it's good within the reserve, but maybe it doesn't help the surrounding areas because it's too large and the fish won't actually then seed outside of it. So the idea is maybe these medium-sized reserves that kind of can do both, help the fish recover in this area and provide sort of a source of fish that can then spread out to other areas. Okay, so that spillover effect is really what we want to think about. All right, and then this is just showing basically some of the successes. So these are areas that have had full protection, and you can see that overall biomass definitely increases much more than in reserves that have been fished. So that's just showing the success of that particular strategy. All right, that's it for today. I hope you learned something. Go back to that initial outline and see if you've gotten all the main points. All right, I'll see you in class.